Hello, my name is Christopher Snyder. I am an MD PhD student focusing on deep learning research. This is an abstract that I wrote with Jared Utrecht and Shiram Vishwanath at the University of Texas in Austin. It's an abstract about the importance of using baseline, simpler comparison models as points to contextualize more complicated neural network models in clinical medicine. So, what we wanted to do was to take an existing model that was published and available in the literature and then try and see if we could run some simple experiments and comparisons to try and untangle exactly what was making that model achieve the performance that it does. So we looked at a sepsis prediction task on the mimic dataset. It's modeled by Kaiji et al. What the model tries to do is to take the previous sequence of clinic visits and then predict of hospital stays and then predict whether on the next day the patient is going to develop sepsis or not, right? And so an attention LSTM model was employed by Kaiji, and this is a model which uses a LSTM on top of a time dependence and then uses attention on top of an LSTM. So it has a lot of bells and whistles, a lot of moving parts. And without these comparisons, it's not clear whether these moving parts contribute to the performance that it actually achieves, right? You just know that the performance is good. So what we wanted to do was to take some time-independent models and see how those fared. So we'll just use a random forest, for example. I'm on the bottom left of the poster. Random forest using the previous day's features to make predictions about whether they'll have sepsis. And with respect to many of these metrics, for example, ROC, you get very comparable results with this time-independent model. So then you come away with a completely different picture of why your model was working. It's not because of the time dependence, right? And then you can ask another question. What about with respect to a very simple predictor, which just predicts sepsis tomorrow if they had it yesterday and never on the first day? We'll call this a lagged predictor. This is on the top of that chart. And the lag predictor achieves worse performance for sure, but it's interesting to see how well it can actually do. On the right-hand side, we get into that more. There's a lot of correlation between having sepsis today versus and tomorrow, and you can do really quite well just using that, ignoring everything you know about the patient, right? So if you can do fairly well ignoring all of the differences between patients and just understanding whether they had sepsis yesterday, then you need to know that to properly understand how good your sepsis model is. So I hope we can use these experiments to build a fund of knowledge about the phenomenology of modeling with neural networks to hopefully improve in the future on new data sets. Thank you.